Hello, ladies and gentlemen, and welcome back to more of the 2001 Cayley Mathematics Contest put out by the University of Waterloo. I, of course, am Root Beer. We're up to question number 23. Hopefully you've had a chance to take a look at question number 23 and try it out for yourself. So, what does 23 have to offer for us? A sealed bottle, which contains water, has been constructed by attaching a cylinder of radius 1 centimeter to a cylinder of radius 3 centimeters, as shown in figure A. When the bottle is right side up, the height of the water inside is 20 centimeters, as shown in the cross section in figure B. When the bottle is upside down, so figure C, the height of the liquid is 28 centimeters. What is the total height in centimeters of the bottle? Okay. So if we take a look at figure B, we've got the big cylinder is all filled up, and then a little bit of the small cylinder has been filled up, and then there's this gap of air in the small cylinder. And in figure C, when the whole thing's been flipped, the bottom cylinder, the small cylinder has been filled up completely, and a large chunk of the big cylinder has been filled up, and then there's that same gap of air, because the volume of water will be the same in both, and the volume of the air will be the same in both. But that little gap of air has sort of been stretched out horizontally rather than all compressed in that tiny little space up there. Okay. And we want the total height of this bottle. Well, it's going to be bigger than 28 centimeters, and if we take a look at each of our answers, they're bigger than 28 centimeters. So, how about we draw the picture? Well, two pictures, actually. We're not going to draw the diagram detailing them, the relationship between the cylinders, because we don't get any information there that we don't already have in figure B. Okay? So, first thing I'm going to do, we want the total height, so we're going to let T be the total height. Okay, so that's the total height of the whole thing. So it's the height of the little cylinder plus the height of the big cylinder. So if we take a look at figure B again, we have that the water is filled up to a height of 20, and that compares to our total height, which is T here. So we'll do the water in light blue. So the water fills up the entire big tank and then a little bit of the small tank. I can't figure out exactly how much of the small tank we have filled out, but according to the picture, and we're going to go by the picture, we fill up the big tank and then we have a little bit of the small tank filled up as well. So if we take a look not at the volume of the water but the volume of air, it's actually going to be T minus 20. So we have a small cylinder of air here, and we're doing it this way because otherwise we'd have to do a cylinder of the big water plus a smaller cylinder of water to get the volume of water. So I'm actually going to compute the volume of the air. It's going to remain constant, just like the volume of water is going to remain constant. But now I have a small cylinder here of height T minus 20 and of radius 1 centimeter. So, well, what's the volume of a cylinder? I know the radius and I know the height. Then volume is pi r squared. That gives us the base of the circle times the height. So in this case, we're going to have pi 1 centimeter squared plus times T minus 20 centimeters. I think I'm going to drop the centimeters here, but we'll get pi times 1 times T minus 20. So that'll be pi times T minus 20. And I think we're going to leave the pi out because we're going to get another equation in terms of a cylinder, and that'll also have a factor of pi, and we'll be able to cancel those out. So that's one way of computing the volume of air thanks to figure B. Now how about figure A? Well, figure A, everything was flipped upside down. So it's going to be the same volume of water, same amount of water. So you can certainly do this question by computing the volume of water 2 different ways, but we're computing the volume of the air 2 different ways. And in figure C, the height of the water is now 28 centimeters, and the total height, T, the thing that we want, stays the same, because all we've done is flip it upside down. And here where the air is now going to have a height of T minus 28. Okay? So if I could just figure out T minus 20, I'd be all set. Just add 20, I get T. If I could figure out T minus 28, I'd be all set. Okay? So once again, we have a nice little column of air, a nice little cylinder of air. Its height, T minus 28, and its radius is 3 centimeters. So the volume of air computed in a different way, and we're going to compare these, and they're both going to involve T, the height that we want, the total height. That's going to be pi times 3 centimeters squared times the height, which is T minus 28 centimeters. So we get the whole thing in centimeters cubed. And here we have pi 9 T minus 28. I'm going to keep the pi out, but I'm going to multiply the 9 inside. 9T minus, well, what's 28 times 9? Grabbing our calculators, because calculators are allowed. And we get 252. Now, the volume of air didn't change. So the volume of air is the same in both figures, same as the volume of water is the same in both figures. So pi times T minus 20 is the volume of air, but that's also the same as pi 9T minus 252. Okay? So pi T minus 20 should be the same as pi 9T minus 252. And just as I predicted, we can cancel out these pi's, and we get an equation just in T, and we should be able to solve it and get T all on its own. So I'm going to collect all my T's on the right-hand side. So that means I'm going to do 9T minus T. And I'm going to bring all my constants, my numbers, onto the other side. So that's negative 20 stays here. And we add 252 to both sides. So that becomes 232 is equal to 8T. And then if we divide by 8 on both sides, grabbing my calculator once again, 232 divided by 8 is 29. So we were able to work out the height of the whole cylinder. And I think that the answers went from highest to lowest. So, yeah, A. All right. So that was question number 23. I believe that's that's also on the Pascal and the Fermat. So they really liked that question this year. So the height of the small column of air in figure C must have been 1. So that would have been 9 pi centimeters cubed. And if we just do a little mental sanity check, in figure B, we have a cylinder of radius 1 centimeter and a height of 29 minus 20, which is 9. So that's pi times 1 times 1 times 9. So that's also 9 pi centimeters cubed. So we just do that nice little mental check once we get our answer 29. The way we've set this up, we have these nice little equations for the volume of the air. And we can very easily double check that, yes, both volumes of the air that we computed are the exact same, given our total value of 29 centimeters that we wanted. Okay? So it's a nice little question. I'll see you guys in the next video for question number 24 as we continue to try and wrap up this 2001 Cayley.